Hello everyone, my name's Dave Smith. I'm going to be talking about delivering on the promise of 5G. How many of you have been less than excited about your 5G experience so far, right? A lot of you. Well, SpeedCheck did a survey late last year, and you're not alone. Most people, a little over the majority, are not super happy with their 5G experience. And you think, well, why? Right? Because of all the hype, 5G's been out now for a while. What is going on? Well, one of the things that is going on is that very often 4G LTE service will give you faster data rates than your 5G service. And this is an example where you run your phone in 4G LTE and you run it in 5G and you see a big difference in performance. There's some really good reasons for that, and it's really not the carrier's fault, but it's true, right? And if you were expecting this big jump in data speeds with 5G, you'd be disappointed. But let me go back real quick to give us a common foundation here. You know, I remember 1G, unfortunately, but at 4G, that's when the different technologies kind of came together into a common set of technologies that the cellular companies used to deliver services. Before then, you know, AT&T and Verizon, they used different modulation techniques. They were incompatible. You'd either have an AT&T phone or a Verizon phone, right? You know, today, that's all been unified. That's great. And 4G LTE did a really good job in providing a new set of services, right? And where we are actually right now is in that orange line between 4G and 5G. So 5G is going to provide all those things that we've talked about before earlier in the day, but we're not really quite there yet. So you have to keep that in mind because 4G is going to be around for a long time. And if you're a carrier, you're going to have to provide service for both, right? So what are these promises of 5G? Well, the super high data rates, multi-gigabits, right? The super low latency and high reliability. There's this thing called availability, right? Means there's a network there to use. That was supposed to be improved because of all the new different kinds of deployment models. And what it all boils down to is that for you and I, 5G would provide a much more consistent, better experience in a larger number of places. And it would do this by the faster data rates, the lower latency, and all this kind of stuff. So those are the promises of 5G, right? And we should hold 5G to that. So why haven't we seen all that? And there's a number of reasons, but the four biggest ones I put up here. One is what's called low band deployments, and I'll explain all these. Another one is high band technology issues. Another is spectrum sharing. You know how I just mentioned 4G and 5G, they have to coexist for a while. You're not going to hear any 4G sunsets for probably 6 to 8 years because there's a lot of devices on 4G right now. And then the last thing is, believe it or not, city, state, and local governments sometimes get in the way. Not intentionally, but they do kind of get in the way. So let's talk about the first one, low band performance. In 5G world, you probably all know this, but they break down the bands into what we call low bands. Those are frequencies that are used that are up to a gigahertz. And then there's mid band, which goes from 1 gigahertz to 6 gigahertz. And then high band, it's everything above 6 gigahertz. You maybe have heard of millimeter wave. Millimeter wave generally today as it's being used is in the 20 to 25 gigahertz range. So it's in the high band, well up there. The awesome thing about low band, anything a gigahertz or below, is those signals propagate really far. So if you're using low band from a tower, those signals are going to go out miles and you'll be able to receive them, great. And those same signals will penetrate into buildings really well as well. So that's all really good. And if you're a carrier and you're trying to roll out 5G service to the widest footprint possible, low band seems like a good answer. And it was initially. The issue with low band is that your data rates tend to max out at no more than 100 megabits per second, which is roughly equivalent to a good 4G LTE connection. Oftentimes it was a lot less than that. So that's where you got that difference between LTE and 5G. That was a low band signal that they were using in that image I showed you. And so unfortunately the carriers, they needed to get 5G out as quickly as possible, right? So they used the low band approach, and it got a lot of coverage, but your data rates weren't what you expected them to be. The other issue, and I love this picture, I got it from Ars Technica, it basically says it all, is the high band stuff. High band was supposed to be that part of 5G that gave you those multi-gigabit data speeds, right? Well, okay, in this picture, there's a guy, he's holding a little device, and it's receiving high band and low band signals. That's the little thing he's holding. And those two charts on the left, the top chart shows you if he's getting a high band signal or not, and then the lower chart is a low band, in this case a 600 megahertz signal. And you can see that as the glass door, it's a clear glass door, kind of comes in front of his device, 600 megahertz goes right through, no problem. The high band millimeter stuff doesn't, it just goes completely away. That means that if you were using a high band channel and you were on a conference call or streaming video or whatever, it would get cut off as soon as that door got in the way. That is the problem with high band signals. You get this awesome data rate, but they don't go very far and they don't penetrate very well. In fact, most things will block them, including your own head if you turned like that. So, high band had some pretty severe limitations in trying to roll it out. The other thing is dynamic spectrum sharing. Now, it's generally a good thing, okay? Compromises are never well received by people, right? Because a good compromise means everybody's unhappy, right? But in this case, it's kind of the best you can do. So in the left side on that, you see you had a 4G world, and there was, low band, and everything was working because it was all 4G. In the second one, when carriers first rolled out 5G service, they rolled it out in low band. And then 4G was still using other channels, other bands, and it didn't work that well, right? You didn't get the performance. And then 3GPP and the cellular standards people came out with a thing called dynamic spectrum sharing to address this coexistence issue of 4G and 5G. And what it does is instead of saying, oh, all the 5G stuff will be in low band and then 4G stuff will be in others, we're going to dynamically mix them because we want the data rates for 5G, right? So we want to use other bands. So we want to dynamically mix 4G and 5G traffic onto the same spectrum. And that works, it does work. But the problem you get is 4G technology loses about, what do I have up there, 20-25% of channel capacity due to overhead. 5G improved on that. They dropped that down to about 14%. That's a good improvement. The problem is, in those parts of the spectrum you're allocating to 4G, you're still losing the 20-25% capacity. In those you allocate to 5G, you're losing 14%. And that mixture, that management, the spectrum sharing management, loses you an additional chunk. So now you're losing a significant portion of your channel capacity. So what happens is dynamic spectrum sharing allows the two groups to work together, but it doesn't do anything for your capacity, right? So that means a lot of times you're going to struggle to get the signal you want at the service level you want using DSS. But it does allow the two to coexist. And I am not saying it's a bad thing. Please don't get that from me. And then the last thing is municipal regulations. I grew up in Southern California, and my whole life, you knew that it took about a year to build a house. And then I moved to the Midwest, and we actually built a house. And it only took about 3-4 months. And I remember talking with the builder, saying, in California, it takes a year. And he said, oh yeah, I've actually built properties out there. That's how long it takes to get permits and inspections and things like that. It just more than doubles the time to build. Similarly with cellular deployments, municipal regulations can oftentimes, especially if to get permits, right, things like that. Unfortunately, municipalities, like any other governmental organization, they're not rolling in dough, right? They need fees to help with their budgets, and sometimes those fees, the cost of them to a single carrier when they're trying to roll out nationwide, they don't want to spend all that money all at once, right? So they have to slow it down. The other thing is, you see that tree there? That's not a tree. You'd probably be able to figure that out already. It's a cell tower. I think that one's in Michigan. I've seen a lot of cell towers disguised as palm trees. And in different parts of the country, municipalities, they have aesthetic rules. And I'm a big wilderness camper, so I kind of like that. But putting up a tower and then making it look like a pine tree, right, takes longer, costs more. So the net effect of city, state, and local government rules and regulations and things like that has been to kind of slow it down. And you notice I haven't said a word about COVID, right? Because that should be obvious to all of us. So I'm not even going to mention that. So what do we do? How do you deliver on this? I just listed all these issues. Didn't sound like there was any quick and easy fixes, right? But there are. So one of the things is, how many of you know about the, 6 to 8 different 3G sunsets that happened last year? There were a bunch of them all throughout the year. In fact, I think with Verizon and T-Mobile had some that occurred on December 31st. Bell, Telus, and Rogers in Canada all cut off 3G service end of December. So as of the end of December, all those cellular resources that were being held over for 3G service are now going to be available for 5G service. And that's a considerable number of resources. Those sunsets last year affected something like 69 million devices, right? That, unfortunately now they need to move to be 4G or 5G, but all those resources that were previously allocated to them can now be allocated to 5G. In addition to that, the move towards mid-band. You remember I said low band, mid-band, high band. The move towards mid-band is going to make a huge difference in how we perceive our service. It's hard to understate that. So hopefully, I won't be here next year and you say, no, you were totally wrong. And then technology advances in high band stuff is coming rapidly. I'm not sure if it's going to come rapidly enough until maybe near the end of the year, but high band improvements are going to really affect things. And then the use of shared and unlicensed spectrum. How many of you know you can use 5G or even 4G LTE in non-licensed spectrum, right? It's talked about a lot, but exactly how does that work, right? Well, the first thing I'm going to talk about is mid-band. And I say mid-band to the rescue because it kind of is. Those of you who have T-Mobile service, you've probably had the best experience with 5G so far. Because when T-Mobile purchased Sprint, they got a great deal of 2.5 gigahertz assets in terms of frequency spectrum. That's mid-band, remember? And they've deployed their 5G service in that mid-band range, and it works awesome. And they call it the 5G UC, right? Ultra capacity. That's their symbol. In addition to that, there is CBRS, which is not a technology, it's a band. It stands for band 48, and that's shared spectrum. And so CBRS 5G is rolling out now, and that's going to allow you to set up temporary or private or enterprise 5G networks to supplement what you need in your cellular service. And then there's this C-band thing. Now, C-band to the rest of the world is a big chunk, but in the United States, we tend to rename things. And so C-band to us is, 3.55 to 3.70 gigahertz is CBRS, and then 3.7 to 3.98 is what we call C-band. And then just below that, we had to pick a different name, so it was called C-band 2, often referred to as that. It doesn't even have a formal name. And that's 3.45 to 3.55. And if you look at that, basically from 3.45 up to 3.98, there's this big chunk of spectrum. And the C-band stuff was licensed or is licensed. AT&T, Verizon, T-Mobile, a number of cellular companies bought significant chunks of that spectrum, and they are rolling out service as we speak. The mid-band service, the mid-band, is kind of the Goldilocks band. I'm not sure how I feel about that name, but I hear it a lot. And it gives you that good, not best, but good propagation and good penetration, and it gives you good data rates. So slower data rates than high band and less good propagation than low band, but it's really nice. It's certainly deployable to cover large areas and service a lot of people. Verizon right now, they say they cover about 175 million with their service, which they call ultra wideband. So if you see ultra wideband, that's C-band technology. And Verizon is saying that they're going to have a nationwide rollout by the end of Q1. We won't hold them to that, right? Q2 is good, right? But they're working to do nationwide rollout. And AT&T says they cover 200 million now, and they want to cover, or 200 million, and they want to cover all those people by the end of 2023. So AT&T is working very hard to get this stuff done as well. So C-band or mid-band 5G technologies are going to make a huge difference to what we see by the end of the year, depending on the carrier you're with, right? Then there's unlicensed spectrum. You have Wi-Fi, 2.5, 5 gigahertz, right? Last year, well, actually a little over a year ago, I guess, they released 6 gigahertz spectrum, and a huge chunk, 1,200 megahertz. One thing you may not know, 5G works so much better if you have a 50 megahertz channel or chunk to use. So if you have something smaller than that, you can certainly do 5G. You're going to get good performance out of it, but you're going to get the full-blown performance of 5G with a piece of spectrum that's 50 megahertz or wider. And that 1,200 megahertz then is tons of spectrum, right, to use. A lot of the unlicensed stuff is going to be in private and enterprise, because a big part of 5G is the flexible deployment models, right? So enterprises, and when I say enterprises, this could be a sports stadium, right? A hospital. These are places where you and I will go, and we can get really good service there. And then there's the high band improvements. This is my favorite area. So there are a number of techniques that have come out. When high band was first attempted to be addressed, basically it was put up a base station and an antenna and broadcast out at really high frequencies, and it just didn't really work, because the weird thing about really high frequencies is they're weird. They do some really strange things. And so 3GPP and the cellular people have defined things like repeaters and smart repeaters. So when you have a high band tower that maybe will cover, get you to the end of the city block, right? A repeater can extend that. So your one cell tower now can cover a bigger footprint. So that's a big deal, because part of the problems in deploying millimeter wave, the high band stuff, is that you have to put out so many cellular towers everywhere. The density is just way too high. In addition to that, they have a new technique is to use cloud-based AI. And now I want to make sure I explain this concept right. To make a number of different base stations look like one base station to you. Now remember, in the cellular world, your phone will connect to a tower, right? And if you move, it'll hand you over to another tower, right? But generally, if you're not moving, you're going to stay connected to that tower. The problem with millimeter wave is that if I'm talking on my phone and I'm standing on a city corner and I turn like this and the tower's over there, I probably just lost my millimeter wave connection. And that's not good. So the tower on that side, which is now meshed with that tower, a seamless high-speed handoff keeps my signal going, right? Oh, wow. Okay, I got to speed it up. Anyway, and of course, fixed wireless access. Fixed wireless access is an awesome application for high-speed millimeter wave functions, right? Fixed wireless access is you got a box, you put it somewhere, and it doesn't move. Like in your home, small, medium business, that kind of thing. They can take advantage of millimeter wave because the things that interfere with that are things that are pretty slow, like trees growing, right? Things like that. And see, I told you it was my favorite slide. But millimeter wave technology, one of the things is, I'm not going to go through all the details here, but there were a lot of improvements in beam forming and tracking and modulating so that the old way of just spewing out a signal is now the beams are targeted at you and they can track you to maintain that connection. There's been a lot of technological advances in the millimeter wave area just to maintain that connection, right? And then the last thing is it's integrated access backhaul, IAB. That's that meshing of base stations so they talk to one another. That's a big departure, right? You know, I mentioned before, you connect to one cell and then you get handed over. Now they're meshing them all. It's a fundamental architecture change, but it's huge. So what should we see? How do we deliver on 5G performance, right? 2023 should be a huge year. We're going to see the network availability go up because of the rapid deployments that we're seeing. Companies like AT&T actually developed a strategy on how they're rolling out. Used to be they'd take 2, 3, 4 trips to a tower. Now they said 1 trip to a tower. That's it. And trying to maximize their speed. The C-band, mid-band deployments, those are going to be huge. By the end of the year, you should actually be happy with your 5G service and the speeds. You should add a 0 to what you're seeing now. And then the last thing is the high-band deployments. When those come out, you're going to start seeing those unique use cases, right? Dynamic controls traffic, remote surgeries by surgeons. I'm not going to do that, but theoretically it'll be possible. So the high band stuff is going to deliver on some of those really cool, unique use cases. You should see all of this hopefully by the end of 2023. So thank you.